the parabola. So here I've got the key features of the parabola. And the first thing I would like you to notice is this parabola is concave up. So it's a positive parabola. That means it has a minimum turning point because that's the lowest part of the graph, so it's minimum. It has a y-intercept where it cuts the y-axis. It has two x-intercepts where it crosses the x-axis. And the line that you could fold your graph over so it's exactly the same as each other is the axis of symmetry. We can also do the same if I had a parabola that went the other way, a sad face, an upside down parabola, or a negative parabola. So this could be in the form y equals minus x squared. That means I have a maximum turning point because my graph has a maximum value. And in this case, it's also the y-intercept. Still has two x-intercepts as well, and it also has an axis of symmetry. So let's have a look at doing some maths with this. Here I have an example of a graph, y equals x squared minus 4x minus 5, and I've said find the coordinates of the turning point. So the turning point is the lowest value of the parabola, and it's where it turns around, which would be the point here. So if I have a look at it, the coordinates of that point is the x value is 2, and the y value looks like it is negative 9. So it's the point 2, negative 9, which gives me the turning point. What is the equation of the axis of symmetry? Well, here is my axis of symmetry. It's the line that cuts my parabola in half. And it actually goes through your vertex. So it's going through the point 2, and the value is x equals 2. So the equation of the line is x equals 2. That is the equation of my axis of symmetry. State the coordinates of the y-intercept. Well, here it is here where it's cutting the y-axis. So that is the point 0, negative 5. State the coordinates of the x-intercepts. Well, you can see it's cutting the x-axis in two places. So the first place is negative 1, 0, and the other one is 5, 0. And what is the minimum value of the quadratic? Well, the minimum value is the turning point, and it's the lowest y value, and you read off the y value for that point. So the lowest value is negative 9. So the minimum value of this quadratic is negative 9. So here is another one that we're going to have a look at, and I've said complete this table of values for y equals negative x squared plus 2x plus 3. The reason I've put this in here is the problems that we have in doing this on our calculators. The first thing you need to realize is that this is a parabola because it's got x squared and then it's got an x and some constant. But it's the x squared that tells you that it's a parabola. Now you know what a parabola looks like, so if you're going to get points that don't look right when you plot them, then you have made a mistake using your calculator. So having a look at this, I'm going to substitute negative 2 into this equation. I'm going to rub that out. So when x is negative 2, in my calculator I've got y equals negative. Now the negative 2 is the thing that gets squared. That negative is hanging out the front, and you could even put in like negative 1. Plus 2 times negative 2 plus 3. And so now you can put that in your calculator, and your calculator will give you the answer of negative 5. And then we're going to do the same for the other points. So I'll do one more. For when x equals negative 1, y equals negative, x has a value of negative 1 squared plus 2 lots of negative 1 plus 3. And you pop that in your calculator and you get 0. Now you could pause here and have a go and see if you can fill this in yourselves. And the answers we should get now are 3, 4, 3, 0, and negative 5. And this should make you happy because you can see along the y value that the points are symmetrical. So now it's just a case of plotting points. So once more, I think you should pause the video, have a go, and plot your points. So your parabola should look something like mine, although a much better version. I would suggest putting arrows on the end to show that your parabola goes on for infinity. So what is the maximum value of the quadratic relationship? Well, this negative sign means that I'm going to have a maximum turning point. So up here is my maximum turning point. And as with the minimum value, it was the y value of that point. It's exactly the same here. So the maximum value of this parabola is 4. So the last question is, what is the value of x given that this is the maximum value? Well, we just need to read off the x value, and the x value is 1. That's all there is to it. I hope this makes sense. If you've got any questions, just ask me in class.